Greetings to Madam Azima. We are from Group 1 and we are going to present fundamentals of logic, which are focusing on basic connectives and truth tables. So here are the group members. I'm Auni as the group leader, and we have Nova, Trisha, and Kalisa as the group members. Without further ado, let's get started with the introduction. What is fundamentals of logic? I believe that logic is the essence of reasoning, and logic is used to determine whether a statement is true or false, and can also be used to deduce the conclusion of an argument. Logic has practical applications in real life, which are to the design of computing machines, to the specification of systems, to artificial intelligence, to computer programming, programming languages, and to other areas of computer science. Based on the topic of the assignment given, which we are focusing on basic connectives and truth tables, basic connectives are symbols used to connect two or more propositional or predicate logics in such manner that reluctant logic depends only on the input and the meaning of the connective used. Meanwhile, truth table is a table that displaying all possible truth values of a statement.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nobatusha binti Nurhaizal, and I will start with primitive statement. A primitive statement is a statement that cannot be broken down into simpler forms, and it is either true or false, but cannot be both. Example: P, a triangle is a polygon. Q, a triangle has three sides. Next, we will move on to the compound statement. A compound statement is a statement that is formed of primitive statement, which logical connective such as negation. For the example, a triangle is not a polygon. Next, conjunction. For the example, a triangle is a polygon and has three sides. Next, disjunction. For the example, a triangle is a polygon or has three sides. Next, we have implication. For the example, if triangle is a polygon, then it has three sides. And lastly, we have biconditional. For the example, a triangle is a polygon if and only if it has three sides. Next, let's move to basic connective. First, we have negation. This symbol is translated as not, or it is not the case that. To illustrate, we can look at the truth table. If the value of P is true, then the value of negation P is false. Second, we have conjunction. This symbol is translated as and or sometimes but. Let's look at the truth table. If both of the statement value is true, then it is true. Other than that, it is false. Third, we have disjunction. This symbol is translated as or. Let's look at the truth table. If both of the statements value is false, then it is false. Other than that, it is true. Next, we have implication. This symbol is translated as if, then. Let's look at the truth table. If the value of P is true and the value of Q is false, then it is false. Other than that, it is true. Lastly, we have biconditional. This symbol is translated as if and only if or if. Let's take a look at the truth table. If both of the values are same, then it is true. Other than that, it is false.
Next, moving on to the truth table. Truth table was a table that displayed the logical operation on input signals in a table format. It identified all possible input combination and the output, which means the truth table will show the result of a complex statement for all possible truth value for a simple statement. How to construct the truth table? First, break the arguments into parts. This includes each preposition, negation, and each connective. The number parts included in the table will determine how many columns are needed. Second, determine how many rows are needed. Since each preposition can only be true or false, which means there are only two choices for each preposition, therefore the number of rows is 2 multiply n, where n is the number of prepositions in the argument. Third, the connecting columns are filled in. Each column is based on the individual parts' true values. Next, let me introduce you to the three natures of compound statement, which is tautology, contradiction, and contingency. Tautology is a propositional statement that is true for all cases, which means it cannot be false. And the contradiction was the opposite of the tautology. Contradiction is a propositional statement that is false for all cases, which means it cannot be true. And lastly, contingency. It is a propositional statement that can be either true or false. From the truth table, we can see that the condition cannot be tautology, neither contradiction, because it has both true and false.
So moving on to examples, here we have three examples where we created our own questions by referring to the past year questions. For example 1, given the following argument, the computer is turned on or the computer is turned off, and it is not the case that the computer is turned on, and it is not the case that the computer is turned off, and the computer is in sleep mode. Based on the argument above, we have to convert it into a logical notation, then determine whether it is a tautology, contradiction, or contingency by using truth table. Firstly is to let the argument above into PQR. So P is referring to the computer is turned on, Q is referring to the computer is turned off, and R is referring to the computer is in sleep mode. Based on the statements we already defined into PQR, we convert it into this logical notation. So next, we have to determine whether the notation above is tautology, contradiction, or contingency by using truth table. First is we input the three statements PQR in our truth table. Next, let's focus on the negation of P, which is the fourth column. So if the value of P is true, then the negation of P will be false. But if the value of P is false, then the negation of P will be true. So this concept will be implied to the rest of the rows in the negation of P. Next is the fifth column, which is the negation of Q. Same thing as the negation of P just now. If the value of Q is true, then negation of Q will be false. If the value of Q is false, then the negation of Q will be true. So this concept will imply to the rest of the rows in column of negation of Q. Moving on to the sixth column, which is P or Q. Consequently, P or Q is true when one of the statement or both of the statement, which is P and Q, are true. If both of the statements, which is P and Q, are false, then the column of P or Q will be false. So this concept will be implied to the rest of the rows in column P or Q. Next is the seventh column, which is negation P and negation Q and R. This result will be true if all of these three statements are true. But if one of the statements are false, then the whole result will be false. This concept will imply to the rest of the rows in this column. Next, we're moving on to the last column, which I label it as A and B. So same as the previous concept, the result will be true if both of the statements are true. Then if one of it is false, then the result will be false. Based on the truth table here, all of the results are false. That means I can conclude that the logical notation above is a contradiction.
Consider the primitive statement P as Razia quit her lunch meal, Q Razia will eat outside, and R Razia is saving money. Express the following compound statement based on the primitive statement given in sentences, and then determine whether it is tautology, contradiction, or contingency by using a truth table.
Now, let's moving on to the solution. The sentence is, if Razia does not cook her lunch meal, then she will eat outside. And if Razia is saving money, then she will cook her lunch meal. Let's take a look to the truth table. From this table, we can see that it has 7 input conditions and 3 input combination, which is P, Q, R. Now, let's go through the table one by one. First, note P, which means it is the negation of statement P in the first row. If P is true, the negation P is false. Same goes to the other hand, where if P is false, then negate P is true. For the fifth column, not P then Q, which means if not P is true and Q is false, not P then Q will be false. Other than that, not P then Q in this column will be true. Same goes to the sixth column, which R then P. In this column, if R is true and P is false, then the condition for this column will be false. Other than that, all the conditions in this column will be true.
Next, for the last column, which we combine fifth condition and sixth condition with the basic connective conjunction, or AND. In this last column, we can see that the condition will only be true if both condition is true. Other than that, all the condition in this column will be false. And with that, we can conclude that not P then Q, and in conclusion, we can see from this table, not P then Q and R then P is contingency.
Now I will explain example 3. Given the following argument, if it is raining, then I am carrying an umbrella, or if it is raining, then I am not going to shopping mall, or if I am carrying an umbrella, then I am going to shopping mall. Let P, it is raining, Q, I am carrying an umbrella, or I am going to shopping mall. Convert the argument above into a logical notation. Then, by using a truth table, determine if the following compound statement is tautology, a contradiction, or a contingency. Next, I will explain the solution. First, we need to convert the question into the logical notation. So, after we convert it, we get if P then Q, or if P then negation R, or if Q then R. Second step, we need to do a truth table. First, we need to insert 3 input, which is P, Q, R. Next, let's focus on if P then Q. So, if the value of P is true and then value of Q is false, then it is false. Other than that, it is true. Next, we have negation R. So, if the value of R is true, then the value for negation R is false. And if the value of R is false, then the value for negation R is true. Next, for the sixth column, we have if P then negation R. So, if the value of P is true and the value of negation R is false, then it is false. Other than that, it is true. Next, for the seventh column, we have if Q then R. So, if the value of Q is true and the value of R is false, then it is false. Other than that, it is true. Next, the eighth column, we have if P then negation R, or if Q then R. So, If the both of the value is false, then it is false. Other than that, it is true. For the last column, we have if P then Q, or if P then negation R, or if Q then R. So, if the value for three compound statements is false, then it is false. Other than that, it is true, even though two of the three compound statement is false. So, for the step 3, we can conclude the conclusion for this question. So the conclusion is if P then Q, or if P then negation R, or if Q then R is tautology.
To conclude, logic plays a crucial role in our daily lives. It helps us make better decisions, solve problems more effectively, communicate persuasively, and understand the world around us. By using logic, we can evaluate different options, break down complex problems, find solutions, generate conclusions, and make predictions based on evidence. Based on this report, it has covered the first subtopic of fundamentals of logic and emphasized how important it is to be reasoning. Logical operations are based on basic connectives such as conjunction, disjunction, biconditional, implication, and negation, which are symbols that join propositional or predicate logics. The construction and interpretation of truth tables displaying all possible truth values of propositions were highlighted in this report. So that's all from Group 1. Thank you.